Hello candidates, and in this module we're going to be looking at what happens if the compounding frequency during the year is different from 1. So far we've only been earning interest on interest at the end of each year in all of our computations. But what happens if we earn interest on interest more frequently than once a year? In other words, we're changing the number of compounding periods during the year. Okay, so that's what we're going to look at. Let's have a look at our slides for this particular area. So our LOS says, calculate the solution for time value of money problems with different frequencies of compounding. So we're changing the frequency of compounding from 1. So we're asked to compute the future value of 1 year from now of $1,000. Okay, so $1,000 is our present value using a stated rate of 6%. Okay, a couple of things to say about interest rates. Interest rates are always quoted as annualized rates, even when the borrowing and lending period doesn't relate to 1 year. Okay, it's really to allow for comparability. The second thing I should say is there are 2 different ways of calculating interest rates. One, ignoring interest earned on interest over the period, and that's known as a stated rate. The other way is quoting them as an effective rate, and we're going to be calculating those in just a little while. An effective rate does include interest earned on interest. What that means is, all things being equal, the effective rate will be bigger than the stated rate, providing the compounding per year is greater than once a year. Okay, and we'll see that as we go through this. Right, so in the exam, you should assume that you have been given stated rates unless the examiner specifically says effective. If he tells you it's an effective rate, then assume it is, and you've got interest earned on interest. Otherwise, always assume stated rates. So we're going to look at this with annual, semi-annual, quarterly, monthly, and daily compounding. So interest being earned on interest once a year, interest being earned on interest twice a year, 4 times a year, 12 times a year, and finally 365 times a year. So let's start off with annual, very nice and straightforward. N equals 1 period in the year. IY is simply our stated rate of 6%. Present value is what we've invested, so $1,000 outflow. Compute future value, and you get 1,060. Okay, I'm going to do that with you. I'll bring my calculator up. Clear off your time value of money. Button, second function future value, and we're good to go. So 1 is N. 6 is IY, $1,000 outflow is PV, compute future value, and there's the 1,060. Now we're going to turn our attention to semi-annual. So now the amount that we've got invested at the end of the first 6 months is reinvested for the second 6 months. And that means the interest that we earned on over the first 6 months will be reinvested and will earn additional interest. So we're earning interest on reinvested interest. What that means essentially is the future value will be bigger. Let's prove it. Now, how do we go about dealing with semi-annual? You might think, well, let's change the number of periods per year. Remember, second function IY, I told you to calculate or set the calculator to 1 period per year. Why not change it to 2? Well, you could do that, but things get a bit messy on the calculator. There's a danger of forgetting to change it back, etc. So that's typically not the way we advise. What we simply tell you to do here is, rather than thinking about N as being number of years, now think about it as number of periods. So when I'm looking at semi-annual, there are obviously 2 periods in a year. So what I'm going to do is simply change my N to 2. So N becomes 2. 2 6-month periods in a year. Now that also means I'm going to need to change my discount rate. So I've got a stated rate of 6%. What that means is over the course of 6 months, I actually earn 3%. So we just take the stated rate and divide by the number of compounding periods in the year to get our unannualized rate of 3%. We're going to put that in as our IY. Okay, so 3. We've already got our present value in there of minus 1,000. So compute future value. Ooh, let's press compute future value. Oh, what have I done now? Oh, I managed to accidentally clear it. Okay, let me do it again. So 2 is N, 3 is IY, 1,000 negative is PV, compute future value. There you go, 1,060.9. It's 90 cents bigger because we've earned interest on interest over that second lot of 6 months. It asks us about quarterly. Well, to do quarterly, n is going to become the number of quarters in the period I'm looking at. Here we're only looking at a year, so it becomes 4. So let's do that. 4 and n. IY becomes your stated rate divided by, this time 4. So over a quarter, the interest rate is 1.5. That becomes IY. And then compute future value. And you can see it's bigger again, 101.6136. Okay, so that's all we're doing. Notice we're increasing n, okay, because we're now looking at the number of periods rather than the number of years. And we're reducing IY. Okay, so in the first period, in the first question with annual, it was 1 period, so 6 divided by 1 is 6. With semi-annual, 2 semi-annual semi-annual periods in a year, so 6 divided by 2 gives us a 3% semi-annual rate. With quarterly, of course, n becomes 4 here, IY becomes 6 divided by 4, okay, so 1.5% over the quarter. Monthly, we're going to divide, n is going to be 12, and IY is going to be 6 divided by 12, so 0.5. And daily, n becomes 365, IY becomes 6 divided by 365 to get the highest future value. Notice as the amount of compounding periods per year increases, the future value gets bigger and bigger and bigger. Okay, now here all we're doing is the other way around. What we're working out is present values. Now with future values, as the number of compounding periods per year went up, the future value got bigger and bigger and bigger because we were earning interest on interest more frequently. Now, of course, with discounting, the reverse is going to be true because we divide through by our discount rate, remember, 1 plus our discount rate. So as a result, what you're going to find is as the number of compounding periods increase, the present value is going to decrease. Let's see if this is the case. So compute the present value of $1,000 received 1 year from now. So that is our future value. Using a stated rate of 6%. Okay, so it's simple interest. It has not got interest earned on interest within it. It's a specified rate or stated rate. And we're going to do it with annual, semi-annual, quarterly, monthly, and daily compounding again. Annual, n equals 1, IY equals 6. Okay, future value 1,000, compute present value 94340. Semi-annual, increase n to 2, decrease IY to 6 divided by 2, i.e. 3, compute your present value, and you notice you've got 94260. Quarterly, n becomes 12, IY becomes, n becomes quarterly, 4 quarters in a year, isn't it? Jumping to monthly there. N becomes 4, IY becomes 6 divided by 4, so 1.5. Compute your present value, 94218. Monthly, well, this time n does become 12, doesn't it? IY becomes 6 divided by 12, so 0.5. And compute your present value, and you get 94191. So notice as we're looking at these present value figures, as the number of compounding periods per year increases, our present value is decreasing. And then finally, daily, n is 365, IY 6 divided by 365, and compute PV at 94177. Okay, let's have a look at a little exam style question to make sure we are comfortable with doing this. So John plans to invest $2,500 in an account that will earn 8% per year with quarterly compounding. So there's my present value. That's my present value. It earns 8% per year. Does it mention effective anywhere? No. So that is my stated annual rate. And so 8% with quarterly compounding, fair enough. How much it will be in the account at the end of 2 years? So let's think about our n here. N is the number of quarters over that period. So 4 quarters in a year. So if I'm looking at 2 years, our n is going to be 8. So we're going to use n equals 8. When we come to our interest rate, we're going to take the stated annual rate and simply divide it by 4, the number of quarters in a year, to get the quarterly rate. So quarterly effective rate, 8 divided by 4, 2%. 2 years is 8 quarters, so that's our n, okay. And they've done it manually here, 2,500 times 1 plus the quarterly rate to the power of 8, and that gives us 2,929.15. Could do it on the BA2 plus, don't mind you doing it that way. N equals 8, IY equals 2, okay, PV, present value, equals minus 2,500, and then of course all we need to do is compute the future value. Right, I'll do it both ways with you on the calculator just to make sure you feel totally comfortable. First I'll do the manual computation. Okay, so we've got the quarterly rate of 2%, the unannualized rate of 2%, so 1 plus that unannualized rate of 2%, so 1.02. Raise it to the power of the number of quarters that we're looking at. So over a 2-year period, that's 8 quarters, so to the power of 8. And that gives us our compounding factor. And then finally, multiply that by 2,500, your investment at T0, and there's 292.15. If you wanted to use the time value of money buttons, let me just clear those buttons. 8 is N, 2 is IY, 2,500 negative is PV, compute FV, and there's the 292.15. Okay, similar question, but this time we're looking at present values. So Alice would like to have 5,000 saved in an account at the end of 3 years. So that's her future value that she's aiming for, FV rather than PV, her future value. We're looking at 3 years. It says the return on the account is 9% per year. Doesn't say an effective rate of 9% per year. So again, that's my stated annual. With monthly compounding. Okay. So with monthly compounding, given that she's looking at 3 years, and we're looking at monthly compounding, N is going to be 3 times 12, which is going to be, of course, 36 in this period. So monthly effective interest rate, well, 9% is the stated annualized rate. Okay, so simply divide it by 12 to get 0.75, which is a monthly, an unannualized monthly rate of return. Then, as we said, 3 years is 36 months. So notice they're doing discounting here. So 5,000 divided by 1.0075 to the power of 36. And that gives you the present value. I don't like that so much. I prefer to write it slightly differently. Although, of course, mathematically, it gives you exactly the same answer. I like to write it as 1 over 1 plus my unannualized discount rate, because that's the discount factor. Okay, let's just get the calculator up on the screen and make sure you can enter that if you wanted to. Okay, so start with 1.0075, raise it to the power of 36 periods. Okay, the 3 years monthly, 36 periods. Take your reciprocal, and there's your discount factor, 0.7641. And then finally multiply by 5,000. And there you go, 382.74. Perfect. Alternatively, of course, you could have used the good old time value of money buttons. So I'm going to do that now. Second function, future value, to clear your data. I know I'm probably driving you crazy by now by saying that every computation. It's because candidates don't do it. They then pick up on data that's stored on a key and get the answer wrong, and then send me emails telling me that their calculator doesn't work. And of course, it's not that. It's just storing data that isn't overwritten. So get used to it. Get into good habits, because then it becomes second nature and you don't even have to worry about it going into the exam. Okay, so 36 monthly periods is N over our 3-year time frame. IY is 9 divided by 12, so 0.75. IY. 5,000 is our future value. So 5,000 FV, and compute PV, and there's the 328.74. So absolutely fine to do it on the calculator if you feel comfortable with it. Choose a method that works for you. Now, earlier I said there are 2 ways of quoting interest rates, either stated, and stated is often known as the specified rate within the contract, and effective. Now, the effective rate is the true rate that includes the impact of compounding. So it includes the effect of interest being earned on interest. What that means is the effective rates are going to be bigger than the stated rates. Okay, that's true of everything unless you're looking at annual compounding when the two will be, of course, exactly the same. So we've got a stated annual rate. Here the LOS asks us to calculate effective annualized rates given stated rates and the frequency of compounding. So we've been given a stated rate of 6%, and remember those stated rates ignore the impact of interest earned on interest. Now banks can quote interest rates either way. So you betcha when you're borrowing money from a bank, you bet that they are quoting you the annual rate because that ignores interest earned on interest, so it will be slightly lower. When you come to deposit cash, i.e. save, you can almost guarantee they will quote you the effective annual rate because all things being equal, it's going to look higher. And they're hoping you don't know the difference between a stated and an effective rate. So we've been given an annualized stated rate of 6% here. Okay, and we're told semi-annual compounding, what would be the effective rate? So to get your semi-annual rate, okay, your unannualized rate, take the stated rate, divide it by 2 semi-annual periods in a year, and that gives us our 3. Okay, and what we're going to do is essentially, to get our effective rates, we're simply going to do 1 plus I to the power of m, the number of compounding periods in the period, and then subtract the one that we added. That's all we're doing. So 1.03 to the power of 2 semi-annual periods in a year, subtract the one you added, and you get 6.09. And look, compared to the stated rate of 6.09 is indeed bigger. Why? Because it includes the fact that you're earning interest on interest in the second lot of 6 months. With quarterly compounding, of course, it's going to go up again. So I here is 6 divided by 4, so a quarterly rate of 1.5. Number of quarters in a year, 4. So 1.015 to the power of 4 less 1, 6.136. It's higher again because now we're earning interest on interest on a quarterly basis rather than a semi-annual basis. So as a number of periods of compounding go up, the effective annual rate will get bigger and bigger and bigger. Monthly compounding, 6 divided by 12 to get the monthly rate of 5 or 0.5%. M is 12, so 1.005 to the power of 12, subtract the 1 you added, 6.168%. So I think it's worth being able to do that manually. I will tell you that the calculator can do it for you, okay? And I'll show you how to do this. Does it save you much time? Not a huge amount, but you may as well know about its existence. So we're looking at the number 2 button here, and above number 2, you'll see written ICOM for interest rate conversion. Press second function and the number 2, and you'll see NOM. Your screen is probably saying NOM equals 0, because you've never used this mode before. I've used it before. I'm going to clear out the data. Now, to clear out data, it's always second function clear equals cancel. The only exception to that is your third row, your time value and money buttons, and to clear them, it's second function future value. Everything else, second and clear equals cancel to clear the worksheet. Okay, let's choose the monthly compounding example here. So NOM on your calculator is just the stated annual rate. I'm going to choose 6 and enter because our stated annual rate is 6. Press your down arrow. It says EFF. Well, that's what we want to compute. So we're going to ignore that. Go down again and you'll see CY. For some reason, this does not reset when you clear the worksheet. Now, if I'm looking at monthly compounding, then I need to tell my calculator there are 12 compounding periods per year. So type 12, then press the enter key. I now can press up once, or if I want down twice, doesn't matter. It will just cycle through until you see EFF back on your screen, hit compute, and there you go. There's the 6.168. Right, okay, compute the effective annual rate if the stated rate is 12% compounded quarterly. Okay, we'll do it manually first of all, and then we will do it on the BA2+. So, stated rate is 12. To get a quarterly rate, an unannualized quarterly rate, take 12 divided by 4, and of course you're going to get 3%. To work out the effective rate, 1 plus your unannualized rate of 3%, so 1.03 to the power of the number of quarters in a year, 4, subtract the 1, and you get 0.1255 or 12.55%. On the interest rate conversion function, so second and 2 to get into interest rate conversion, second and clear equals cancel to strip data out, apart from that CY that doesn't seem to clear. You have to do that manually. Okay, stated rate 12. So enter that as your nominal rate. Stated 12, enter, down again to get CY. We're looking at quarterly compounding, so 4 and enter. Then you can go down twice or up once to get effective back on your screen. Hit compute, and there's 12.55. So nice and straightforward. Also, of course, the calculator can go the other way around. If you give it an effective rate, it can compute a stated rate.